Hey guys, how's it going? Today we're just going to talk real quick about evaluating a couple of types of nonlinear functions. Now we talked quite a bit this year about linear equations and linear functions. And here's the deal, right? So for anything that's linear, right, we said that our general formula we like to use is the same slope-intercept form. All we're doing right now is putting an f of x in front of it. But here's the deal. It was linear, and you can only, if it was linear, you can only have the following things. You could have addition, you could have subtraction, you could have multiplication, and you could have division. And even division is a little bit iffy, and we'll talk about that a little bit later, okay? But these are the only four basic operations you're allowed to have. If you only had these four basic operations, it created a straight line when you graphed it, right? And therefore it was linear. We'll talk about the constant rate of your slope was constant, it was always the same. What we're going to start working on now is nonlinear functions, okay? So these things have other things besides addition, subtraction, multiplication, division. Now they can still have all these things, but they're going to have a couple extra things added onto them. So absolute value, which we talked about yesterday, was, you know, something like this. I'll use it, not use F, let's g of x would be something like this, absolute value of x, okay? Where it's going to have some absolute value. Now, absolute value is not addition, subtraction, multiplication, division. It's something different. Therefore, as we get through this, the slope will behave differently, and the graph will look differently. When we graph these, it will not make a straight line. It'll make a straight line that bends, okay? Quadratics, which I know we haven't gone over what that word means, like quadratic word. That's going to be a big part of your curriculum next year. We'll use a different h of x. It's going to have an exponent of 2. Okay, we're going to be squaring. So again, this is not addition, subtraction, multiplication, division. This is exponents. Okay, and the last one we'll talk about are radicals or square root functions. J of x. Okay, and we'll call this, you know, something like this. Now, earlier in the year when we did some other things with square roots, I told you need to take the positive and negative square roots. In this case, that's not true. We only want the positive one. When we actually go over proper functions and we start looking at graphs, you'll understand why we're only allowed to have a positive answer. Part of the definition of a function is that you're only allowed to have one output. So in this case, we have two outputs, positive and negative. We have to choose one. We have to choose the positive. Okay, so all those things I told you about making sure you have the negative answer, making sure you have the negative answer, you can throw that out the window for the time being, okay? You guys are going to see that sometimes you just want the principal square root, the positive square root, and then sometimes you want both. It really depends on the situation. In this case, we just want the positive one, okay? So all we're going to go over today is what's going to happen when they ask you to evaluate some of these types of nonlinear functions, okay? So say they told you this. They said f of x was equal to -3 times the absolute value of -8 plus x. Okay, and they want to know f of 3. Okay, so all they're saying is this is your function, and they want it evaluated at 3. Okay, so all that means is everywhere I see an x in here, I'm going to plug in 3. Okay, so we're going to say f of 3. Again, remember, this is not something you're evaluating. This is just by itself. F of 3 is equal to -3 times -8 plus 3 inside the absolute value. Okay. First and foremost, you do not distribute. You cannot distribute here. You can't distribute this negative in here, okay? These absolute value signs exist as parentheses, but you are not allowed to distribute, okay? So for right now, let's just go ahead and let's evaluate this. We'll leave the -3. Again, let's do, again, parentheses first, right? -8 plus 3 is going to be -5. So we have -3 times the absolute value of -5. Well, the absolute value of -5, remember, anything that comes out of the absolute value sides has to be positive, right? So these are going to come off, and this is going to become positive. So this becomes 3 times 5. So we would say that f of 3, in other words, this function evaluated at 3 is -15. Okay? So again, nothing crazy here. What do? We substituted, we multiplied. The only thing that was new about this was that what we talked about yesterday. This absolute value will make this positive. Okay? So we would say f of 3 is equal to negative 15. This function evaluated at 3 is negative 15. Again, if you were going to graph this as a point, this would be the point 3, negative 15, right? This is x, and what we used to call y is now x. All right. The next one we'll talk about, we'll say f of 2, I'm sorry, f of x is equal to negative 12, sorry, negative 12 plus x squared, and they want f of 2. In other words, they want you to plug in 2. So I don't know why I drew an extra line there. That's what Jesus. We're going to plug in 2. All right, so wherever we see a x, we're going to replace it with 2. So we'll say f of 2, the function evaluated at 2, is equal to negative 12 plus 2 squared. Negative 12 plus 2, last I checked, would be negative 10. Please be very careful how you put this in your calculator, okay? You need to have those parentheses because this and this are two different things, okay? And if you put this in, your calculator will give you the wrong answer. It will tell you that it's negative. This is negative 10 times negative 10, which is 100, okay? So again, what we say, f of 2 is 100, and if you want to think about that as a point, it would be the point 2, 100. If I said f of 9, so f of x is equal to 9x minus x squared, and they want f of 9, okay? So let's plug it in. F of 9 is equal to 9 times 9, put inside parentheses, minus 9 squared, okay? Please make sure you put this inside parentheses. Again, we want to make sure we get the right answer. You can't have that negative in the front. 9 times, well, let's do the 9 squared, right? Let's do our proper order of operations. 9 squared is 81. Okay, now we can drop those parentheses. And again, what would our next step be? Do the multiplication part. 9 times 9 is also 81. The further you guys get into this kind of stuff, I know we're very set in our ways of doing order of operations, right? We do the parentheses first, and we do the exponents, and we do multiplication, division, and we do addition, subtraction. Well, all the addition subtraction stuff is last, so you can kind of treat these like little bubbles right here because you know that you're not going to do anything until the last step of addition and subtraction. But if you need for the time being to take them very step by step, then please take them step by step. Bar none, 81 minus 81 is 0. So what will we say this point would be? 9, 0. Okay, or x intercept. All right. Long. If I said, all right, I'm going to go g of x this time, just so you guys don't get so caught up in being f of x. G of x is equal to 3, 10 minus x squared. And they want this evaluated at negative 7. Oh my God, watch your negative signs. Watch your negative signs. Okay, you have a minus and negative. Okay, so again, g of negative 7 is equal to 3 times 10 minus negative 7 squared. Okay, so again, let's do our parentheses first. 10 minus negative 7 is actually 10 plus 7, right? This is double negative. So this becomes 17. 17 squared is, I have no idea. 289? 289? 289. Ford Mustang motor. Okay, all right. G of negative 7 is equal to 3 times 289. That one I don't know off the top of my head. 3 times 289 is going to be 867. So what would we say? G of negative 7 is equal to 867. It was 867, right? Okay. So again, not the most simple answer, but nothing that we can't handle, right? A little calculator help us bail us out, right? So again, what are we going to do? We're going to plug in this number, okay? So all they really want is this, okay? They just want to know when you evaluate the function, what you get. I keep giving you guys these are the points. If you were graphing it, you're not going to be graphing it for your homework, so don't worry about it. Okay. Let's do one with a square root. Don't freak out. F of x is equal to 9 times the square root 74 plus x, and they want f of 26. Now, before you freak out, because it's a square root, don't worry, okay? F of 26. Everywhere you see it, an x you're going to replace with 26. 9 times the square root of 74 plus 26. If you guys don't know, you should know. Anything that's underneath the square root is inside parentheses. This is really something like this. You have to do anything inside here first. Again, no distributed property, nothing like that. Okay. So again, 74 and 26, last I checked, was 9 times the square root of 100. So that would be, the square root of 100 is 10, and 9 times 10 is going to be 90. So f of 26 is going to be 90, right? When we get to radical functions, square root functions, we're going to choose nice numbers to put in here so we get out nice answers, because most of what we get will be irrational nonsense. Okay? I'll give you a couple with fractions or decimals. F of x is equal to x squared, right? Harmless enough, and they want f of 2.4. Don't freak out. Don't freak. It's the decimals. Right? You have probably a calculator nearby, and you're going to say, what's 2.4 squared? Right? 2.4 squared is going to be 5.76. So f of 2.4 is equal to 5.76. Don't lose your mind just because they gave you a decimal. It's the same rules. You're just plugging this in. Okay, and the last one, I'll give you a big decimal, and you guys can not freak out about it. F of x is equal to 4.77 times the square root of x minus 46.18, and they want to know f of 47.18. So again, don't freak out. These are going to work out nicely. So what are we going to do? We're going to plug in 47.18, 4.77 times 47.18 minus 46.18, which very conveniently turns out to be 1. So f of 47.18 is equal to 4.77 times the square root of 1, which means that f of 47.18 is equal to 4.77 times 1, which means that f of 47.18 is equal to 4.77. Okay? So again, no reason to freak out. It's just decimals. Okay? If you have to use a calculator for that, go ahead and use a calculator for it. If not, do some long decimal third grade work and have fun with it. Okay? So anyway, I hope this helps. I'm going to send you guys some work, get it done, and I will talk to you guys tomorrow.